So in today's lecture we are going to talk about the topic called resolution of vectors. Yesterday's lecture was regarding the law of parallelogram of vector addition, in which we have studied how can we add two vectors of the same type whenever its magnitudes and the angle between them was given. We had a formula to find how much is the magnitude of the resultant vector and how much, and rather what would be the angle made by the resultant vector with respect to one of the two vectors. We try to find it with respect to horizontal. In today's lecture we will study a topic called resolution of vectors. Once again, this topic of resolution of vectors is going to be extremely important topic, because every time you are going to study motion of an object or the forces acting on the object or certain electric field or any kind of magnetic field, to simplify the study of that particular field or that velocity or the displacement or the force, one has to resolve vector into its components. Even in order to study the projectile motion or any other kind of motion in two or even more dimensional plane, one has to think of resolving vectors and then to study those vectors. So this topic which we are going to study is going to be a very important topic, and please make sure that you all understand this topic very properly. So just write the title as resolution of vectors. Now listen to what I say. Earlier in the previous videos which were sent to you and which you all must have seen in our video lectures and even in our simulations, I have right in the first and second video of this chapter of vectors or mathematical methods, I have spoken about unit vectors. Now what exactly is meant by a unit vector? A vector which is having magnitude equal to 1 will be called as unit vector. But if I say magnitude equal to 1 can have any kind of direction. So it means that you will have unit vectors in all possible directions. Then how can we decide unit vector in certain direction? That also we are going to try and find out today. To have a simplicity, we specifically choose unit vectors along x, y and z axis. That whenever you consider one unit along x-axis, it will be represented as I cap, which we have been speaking about. So unit vector along x-axis is always to be considered as I cap like this, and the same magnitude along y-axis it will be considered as j cap. Now because my diagram is in 2 dimensions, I cannot have a 3-dimensional axis shown to you. Of course I can have its perspective diagram as some 3 dimensions, third axis taken somewhere in this direction. Time being I am not drawing it. But if at all I have some z axis pointing towards you all people, one unit along that will be considered as the unit vector along z axis and it will be taken as k cap. So we have got 3 unit vectors most of the times, I cap, j cap and k cap. They are the unit vectors along x, y and z axis respectively. What I just do is, I choose any point P somewhere in this xy plane such that the coordinates of point P, let me consider those coordinates to be something called as x, y. So here I have a point P somewhere in this particular position. Let us say this P is a point, the coordinates of which are given by x, y. Then if I join this O to point P, this particular vector O starting from O and reaching up to P, it is called as the displacement vector. Now this, or rather I can say it is position vector rather. So position vector of point P is O to P. What is meant by displacement vector? Even that I will speak about. That if I have any point P over here and some other point Q over here, the vector starting from P and ending up to Q will be called as the displacement vector in that particular case. But anyway, time being, I will just talk about this vector OP, and then I understand that this particular vector OP here, its magnitude is something called as P, and I represent that vector as vector P. So I will say that let your vector OP be considered something like vector P such that its magnitude of vector OP is only equal to P. म्हणजे त्याची length किती असेल तर it may be having some 10 units. I do not know. So some 10 units, then its magnitude is equal to 10. If this magnitude is equal to 15, I will say that this vector OP has got magnitude equal to 15, such that this point P has made some angle theta with the positive part of x-axis at origin. That's what my consideration is. How do I understand how much is this vector? For that we have earlier studied triangle law of vector addition. I simply drop a perpendicular from point P on my x-axis, and if I drop such a particular perpendicular, the foot of which is lying at some point called as M, then I understand that O to M, this length, how much will this length be equal to? If this coordinates were x, y, this distance O to M will be equal to x. That's a simple coordinate geometry that we know. And how much will this, if I drop a perpendicular from P on my y-axis, and if the foot of the perpendicular lies at some point called as N over here, this ON becomes equal to y. Is that alright? So I then find that this ON is therefore equal to x and this MP is equal to y in magnitude. What does triangle law of vector addition say? Triangle law says that this vector OP is equal to vector OM plus vector MP. Is it not? So triangle law says something like this. So if I just drop a perpendicular from here, maybe as earlier I was saying, this part OM is equal to x in magnitude and this part ON is equal to y in magnitude. Then in triangle law, if I say that vector OP is actually equal to vector OM, this vector OM plus vector MP, this vector OM plus vector MP is going to give me that. So that therefore, I would say that vector P, vector OP itself is equal to vector P, is equal to, how much is vector OM equal to? Then I have got a very simple idea. Because 1 unit along x-axis is equal to I, 2 units along x-axis will be equal to twice I, 3 units along x-axis will be equal to thrice I, so x units along x-axis will be equal to x times of I. So this is OM vector is going to be equal to xi cap plus this vector MP is going to be exactly same as that of vector ON because two parallel vectors which are equal in magnitude are equal. Then how much is this equal to? Then vector ON is equal to j times of y or y times of j. The same logic which I have used earlier. So therefore even your vector MP is supposed to be equal to y times of j, and therefore I say that vector P is equal to, it is xi cap plus y j cap. Here, now I understand that this vector P is made up of two components. It's made up of two parts. One is this xi cap, the other is yj cap. So these two are basically the parts of that vector. This resolution means to resolve, to separate. To separate a vector into its constituent components is called resolution of vectors. So here I understand that this vector OP or that vector P is in fact made up of two components. One is xi cap, the other is yj cap. They are my resolved components of vector P. Here I have actually started in a different approach. I have taken some point P over here and I have got what is my vector. Now I'll start doing the actual resolution. Actual resolution means I know what is the magnitude of vector and I know what is the angle made either with respect to horizontal or with respect to vertical. Now horizontal and vertical are basically my reference lines. You can have any kind of reference lines in case of vectors. But time being, now I understand that this vector OP or rather that vector P, the magnitude of which was only equal to P, it could be 10, 15, 20 as we have already said. If this vector is making some angle theta with your x-axis, what are going to be the two parts, perpendicular parts of which this vector is made up of? That's what I am trying to find. So that here I understand the same diagram, its smaller scale, I am showing that this is vector P making some angle theta with respect to x-axis, and you see it's the same diagram that I am drawing. This is O, this is point P, and if I drop a perpendicular from here, this is my point M. Now this x was one of the components, y is the other component. I want to find what are the values of x and y in terms of P and theta. That if I know what is this magnitude, maybe 10, 20, 30 and the angle made if it is equal to 30 degree, 40 degree, 45 degree, 60 degree with respect to x-axis, I want to find what are the components of that vector. So in this triangle, you try to find what is sine theta equal to. Come on. So in triangle, I go for this big triangle. Actually, the same replica has been shown over here. It's OMP. In this triangle OMP, you have what is sine theta equal to? Sine theta is equal to, you find it as opposite upon hypotenuse. So it's PM divided by OP. Am I right? Feel free to give answers. It is PM divided by OP. And what about cos theta then? Adjacent upon hypotenuse. So that is equal to OM upon OP. But what is OP in magnitude? It is P. You know its magnitude. How much is PM? X. I want to find that. No, this is Y. I want to find this. How much is OM? It is equal to X. I even want to find that. So therefore I find that this PM is equal to, it is OP means P sine theta and this OM is equal to P cos theta. So therefore PM means Y. So therefore I find that X is equal to something and Y is equal to something. So I find X means OM is equal to P cos theta and Y is equal to P sin theta. They are the two resolved components of this particular vector. What do I mean by this? By doing all this thing, what have I achieved? I'll tell you. That supposing at all I am considering that an object is thrown like this. If I say an object is thrown in this particular direction, such that now this is something like velocity v, and this velocity v with which the object is thrown is, let me say, something called as, this velocity v is equal to 20 meters per second with which I want to throw this object. 20 meters per second I have thrown an object such that it is thrown by making some angle of 30 degree with respect to horizontal. जमिनीशी केलेली angle जी आहे, that angle is equal to 30 degree. This object is going to travel along x-axis as well as along y-axis. Because I am throwing it obliquely, it's also going to travel ahead and it's also going to travel up. Then I can resolve this velocity of 20 meter per second or its speed as 20 meter per second speed into two components. One is along x-axis, the other is along y-axis. In fact, I am simultaneously giving two velocities to this particle, one horizontally, one upward, and its addition turns out to be equal to 20 meter per second. Now whether it is right, let me try and see. So this component I will call it as V along x-axis, this component I call it as V along y-axis, and I already have formula for them. That if theta was the angle made over here, this is its adjacent component, and adjacent means cosine ratio. Whereas this vertical becomes its opposite component, and opposite means sine ratio. So you have your Vx value is equal to, if at all theta is equal to 30 degree, I am assuming, then you find that this Vx is equal to, it is V sine of 30 is equal to 20 multiplied by sine 30 is half, so it is 10 meter per second. And Vy, the component of vertical component of velocity, वर किती स्पीड ने फेकलाय त्याच वेळेला, तर that is equal to V x should have been equal to cos theta component. It was V cos of 30 degree I should have taken, and cos 30 is equal to root 3 by 2. So this velocity is not only 10, it is supposed to be 10 root 3. 10 root 3 meter per second. Whereas what is Vy equal to? The Vy is opposite component. We have said y component is equal to, in this case, achha, where was that? I have cancelled it. So I'll just better write it once again. That y is equal to p sine theta, and here you understand that x is equal to p cos of theta. So the y component of this velocity is equal to, it is V multiplied by sine of 30 degree, but sine 30 is half, so that will give me only 10 meter per second. Now whether these resolved components are correct, I have to ensure. If at all these two resolved components are correct, means if I replace this vector, म्हणजे vector काढूनच टाकलं, I do not impart this velocity to the particle, but I impart two velocities to the particles, one along x, one along y. असं जर का दिलं, still the particle has to travel in that direction, or still the net velocity of the particle, resultant velocity of the particle has to be equal to this much. Now whether it is right, let me try and check. So this is now going to give me that V is therefore equal to, now see I have given Vx and Vy like this. Vx किती आहे, तर Vx is equal to 10 root 3. How much is Vy? The Vy is equal to 10. How are they acting? They are acting perpendicular to each other. Yesterday we have studied that parallelogram law, that whenever two vectors were acting perpendicular, the resultant was equal to root of p squared plus q squared. So here in this case, that V total velocity will be equal to square root of Vx squared plus Vy squared. So it's equal to square root of Vx squared means 10 root 3 square. What is 10 root 3 square? It is 100 into 3, that is 300. Plus Vy squared means 10 square. So 10 squared is 100. So it is going to give you square root of 300 plus 100 is 400, but square root of 400 is 20. So you get that the total velocity of the particle is equal to 20. So I have proved that instead of that 20 meter per second acting here, I can assume that the particle is not having that 20 given to it. but in fact the particle is given 10 root 3 here and 10 over here. That is what I mean by resolution of vectors. That's what you have to understand by resolving a vector into its components, so that henceforth whenever you have any vector x, y, v, force a cell f, any vector can be always resolved into its two components in the two-dimensional plane. One is, if the vector is r, it will be r cos theta, r sin theta. If the vector is velocity, it will be v cos theta, v sin theta. If the vector is force, it will be f cos theta, f sin theta. But you have to always keep in mind what is the angle made with respect to what. Such that now in this particular case, because theta was the angle made over here, this was its adjacent component, so it will be p cos of theta is here. So x is equal to p cos theta comes here. And because this is the opposite part of that angle theta, this other component of vector is opposite component and it will be equal to p sin theta in this particular case. Do you understand what is meant by resolving a vector? So this is all about resolution of vectors, and I would now suggest you all to just get all these things written over here. So in this earlier part of resolution of vectors, we have studied that if at all you are given a vector OP given as xi cap plus yj cap is any general vector, how can I find what are the values of x and y? The value of x comes out to be equal to p cos theta, the value of q comes out that y comes out to be equal to p sin theta. In fact, what we have done here under the title of resolution of vectors in mathematics, you are considering that as the conversion of rectangular coordinates to polar coordinates. You see, if I have any point in the xy single plane, to specifically mention that point, I have to give it some coordinate. Those coordinates are considered as x, y. So if I say a point 5, 7, it means I am exactly locating that point 5, 7 such that if you consider its perpendicular drop from that particular point along x-axis, it will be dropping at 5, on y-axis it will have a drop at the foot of the perpendicular will be at 7. So any point is going to have unique coordinates. Similarly, the other way of representing a point in the xy coordinate system is r, theta, called as polar representation of coordinates of a point. What do I understand by that? That I just have to mention how much is the distance of P from O. That distance OP has to be known to us. Now if I say that distance OP is equal to something like 20 units, but OP distance is 20 units, will cover all those points on the circle whose center is at O and radius is equal to 20. This सगळे points cover त्याच्यामध्ये. Now which exact points I am going to talk about? Then I need to represent this angle theta as well. The point which is at 20 units and making an angle of theta is equal to 30, like we have considered that for velocity. Velocity was 20 units and making an angle of 30 degree with respect to your x-axis. So that was very specific. So once you know x, y, you can convert those x, y values in terms of using theta, or that r, theta. If I say distance is r, it will be converted in the form of r, theta, and also vice versa, that if I know what is r, theta, I can find what are the values of x, y. So this is conversion between rectangular and polar coordinates. In mathematics teachers will teach you under that particular title, but it's all basically the same idea. Now what I mean to say in all these cases is that if at all I have my vector OP given by xi, yj, I can first of all find what is the magnitude of vector OP. And to find the magnitude of vector is always going to be very simple. that if I say vector OP is equal to vector P is equal to xi cap plus yj cap, if I write, then the coordinate, the magnitude of this vector is very simple for me to find. Magnitude म्हणजे याची किती length आहे, so I can use Pythagoras theorem that this p squared is equal to x squared plus y squared. You have, so since we have p squared is equal to x squared plus y squared, therefore p is equal to square root of x squared plus y squared. Now what is value of angle made by such a particular thing? That angle is equal to theta. And what do I know? I know what are the coordinates of x and y. So I can easily find what is the angle theta. Then I understand tan theta is equal to opposite upon adjacent. So you understand here that tan of theta is equal to opposite is y divided by adjacent is x, and therefore tan theta is equal to y by x. Theta will be equal to, it is tan inverse of y by x. That's what you get. Such that when I knew what were the values of x and y, I could find what was the magnitude of vector, and I could find what is the angle made by the vector. If you have it the other way around, जर तुम्हाला p and theta माहित असतील, तर how to find out x and y? We have already done that. Correct? Which means that supposing if I say that I have got any one more thing which I would like to mention here is about the unit vector along this vector. Now what's meant by unit vector? Unit vector is a vector having magnitude equal to 1. So this unit vector along x-axis was I, along this it is j, along this that unit vector, I do not know what is that, I will call it as u cap along p. Some unit vector along p. How much is that and how can I find this out? Then the formula is very simple, which we have already studied, that unit vector is always equal to vector divided by its magnitude. So you have unit vector along p is equal to vector p divided by magnitude of vector p, but vector p is equal to all this xi cap plus yj cap. So it is xi cap plus yj cap divided by its magnitude is square root of x squared plus y squared. So this will be the unit vector along that particular vector. Say for example, if I take one such case over here such that supposing a vector p is given by, it is 10 root 3 I cap plus 10 j cap. This is the vector. I want to find what is the value of magnitude of this vector, what is the angle made theta. What are the result components? They are directly seen. Along x-axis it is 10 root 3i, along y-axis it is 10 times of j. That's directly seen over here. But if I want to find what is the magnitude of this vector, instead of p I can write it as v. This is exactly the same, these are going to be the same values exactly which we have considered in our previous example. So here the magnitude of v will be equal to square root of x component squared plus y component squared, that is equal to 10 root 3 bracket squared plus 10 squared. So that is going to give me v is equal to square root of 300 plus 100 is 400, means equal to 20. So that's the value of v. How much is the angle made by this vector with respect to horizontal? That also we have a formula for that just now written, that tan theta is equal to y by x. What is x and y here? X is this, y is this. So I'll go for that. Tan theta is equal to y by x, means y component here is 10 divided by x component is equal to 10 root 3. So that gives me only 1 upon root 3. So you understand that tan of theta is equal to 1 upon root 3. But what is, which angle do you have whose tan comes out to 1 by root 3? tan of which angle? 30 degree. Tan of 30 degree comes out to be equal to 1 by root 3. So therefore you have theta is equal to tan inverse of this is only equal to 30 degree. Now you see it will exactly match with whatever we have seen initially. That in the previous case I started with the velocity given to be equal to 20 meter per second was the velocity given and the angle was given to be 30 degree. And I got what were the x and y component values. I got them as 10 root 3 and 10 if you see in your example. Exactly. Now I started with x and y components and I got to what is its magnitude and what is the angle made. The next thing I can also do here is what is the unit vector along this velocity. The unit vector along this is given by unit vector is equal to vector divided by its magnitude. So it will be equal to all this 10 root 3 I cap plus 10 j cap entirely divided by this is 20. So it is then equal to, if I separate, it will be 10 root 3 upon 20 I cap plus 10 upon 20 j cap. So it becomes automatically it is root 3 by 2 I cap plus 1 by 2 j cap. So that becomes your unit vector along this vector as well. So today in this particular case, if you see, we have solved almost everything and we have spoken almost everything about the conversion of vectors, a vector to convert a vector into, you can say its components. If at all you know what is its magnitude and angle. The components of vectors, henceforth you just keep in mind that the components of vectors will be, supposing if you have p as a vector, it will be p cos theta, p sin theta. If you have velocity as a vector, v cos theta, v sin theta. But if at all the angle made with this y-axis is theta, then in that case this becomes your adjacent. V cos theta that cos theta component will be here and the other one will become sin theta component. So these are very simple things that you all just have to understand. As we progress in our next lectures, we will solve more and more examples so that you can understand the things in much better way. Now what you all just do is you write down all these things and we will meet once again in the next lecture. Thank you.